We know from the previous example, example of Daniel cell, that metallic cathode is gaining mass during the galvanic cell work. So now we are able to figure out that the mass of the silver plate was increased by 0.166 grams. So let's try to find out how many moles it was. Yes, molar mass of the silver is equal to 108 grams per mole. So the number of the silver moles which were deposited on the surface of the plate is equal to 0.166 through 108 give us 0.0015 moles of the silver. Okay, we need to also find how the concentration was changed. Yes, so we need to calculate how many moles was in the electrolyte solution before the process, before the galvanic cell start to work. So we know that the molar concentration of this electrolyte, silver nitrate electrolyte, is equal to 0.1 moles per cubic decimeter. It means that the concentration of silver cations is equal to 0.1 moles per cubic decimeter. Yes, so in I maybe will stay using decimeters. So in 1 cubic decimeter we have 0.1 moles of the silver cations. However, we have not 1 cubic decimeter because we had an information that these metallic bars were immersed in the electrolyte solution with a volume of 50 cubic decimeters. Yes, so in 50 cubic centimeters. So in 50 cubic centimeters, which means 0.05 cubic decimeters, we have an unknown number of the moles. So the X is equal to 0.005 moles. So now we need to write very simple equation. Yes, very simple equation. 0.005 moles of the silver cations before the process minus 0.0015 moles of the silver cations which were deposited on the surface of the silver plate. Yes, so after the process in the electrolyte solution remain 0.0035 moles of the silver ions. What is the new concentration? What is the new concentration of the silver cations? We need to calculate. Yes, in 0.05 cubic decimeters. Now, after the process, we have 0.0035 moles